going to see the meaning of the delta function of Dirac and why it is not a true function, it is a operator. So let's get to this by the impulse meaning. So we know we have second law of Newton, force is equal to mass times acceleration. If we integrate both sides with respect to time, we have force times time is equal to mass times what's the integral of acceleration with respect to time, because mass is a constant, so for that I can put it out. Is mass times velocity. So here we have impulse, this is called impulse, and this is called momentum, or rho. Alright, so if we want to find the impulse, here the impulse is the integral of a function. Well, here was force, but I could put any function d or whatever in dt. My function is d in dt. This would be equals to the impulse. So let's say that I want to have an impulse of 1. So for example, my function would be defined as d is equal to 1 over e if time is a is less than the time. You will see why I'm putting this. So here I have the graph of d. So between a and a plus e, I have that my function is 1 over e, whatever it be. If here is 1, let me say that here is 1 over e. So this, and otherwise it is 0. So 0, 0. Alright. So if I wanted to know the impulse of this function, that is the integral, let's say from a plus e, from a to a plus e of my function d in dt, this would be equal to, well, this is the integral, this would be, first, what's the, intuitively, it would be, this is a rectangle, so it would be width times height. The width is e, the height is 1 over e, so I would have 1. So this would be equals to 1. Other way to put this is the integral from, you can put it from 0 to infinity, because all the time is 0 and it just only counts here, from 0 to infinity of d in dt. This is equal to 1 also, because here you have the integral of d with respect to time is d times time, and this goes from a to a plus e. So this is the function, here the function, wherever it be, times a plus e minus a. But what's the function? The function on this interval from a to a plus e is 1 over e, so times e, this is 1. So this was my function defined as this. In a while you will see that this would be called the delta function of Dirac with some arrangement. But now here you can see that this is the function that has the impulse of 1. So now let's see the limit as e approaches 0. 0. So instead of being here, for example, now I have it here, a plus e, etc. So I want exactly at just a. So from a to a exactly here. So I would not have 1 over e. What would be 1 over e? This would be the same as 1 over 0 from a less than t less than a plus 0 is a. Otherwise would be 0. Sorry, here was time different than sorry, otherwise. So here I have now I have 1 over 0 is infinity from, this is just where t equals a, and 0 otherwise t different than a. So that means that on the graph now, here I just have a point in which the graph disparates and goes to infinity. In this point it goes to infinity. And otherwise here we have 0 and 0. This, you know, this is the delta function of Dirac, that in one point it goes to infinity. And the integral of this function, the integral of the Dirac function on dt, this doesn't mean partial, this is just dt, this would be equals to 1, because we have 1 over e multiplied times e, it was 1. But here in this case it was 1 over 0, it was infinity, multiplied by e that is 0. So this would be undefined. We have other ways to see that this would be 1, so this would be the unit step function. The Dirac function, the delta function of Dirac is the derivative of the unit step function. Alright, anyway, so now here we have this impulse, and now let's say that we want, first let's remind you the integral from, let's say, a to a plus e of another function, whatever it be, g of t in dt. This would be g of t times time evaluated from a to a plus e. So this would be g of t times a plus e minus a. So it is just g of t, it is 1 over e times g of t. If we now want to take the integral from a to a plus e of this whatever function it be, g of t, times the delta function of Dirac in dt, this would be equal to, the delta function of Dirac is just 1 over e, so we can, this is just a constant, so we can take it out. So we have 1 over e times the integral from a to a plus e of g of t dt. So this is 1 over e times, all this was e, well, what I was here, so it was e times the function. So this is just the function. And when we are talking about t equals a, so that is what's the integral from a to a plus e of a function times the delta function of Dirac when the time is equal to a. This would be the function itself evaluated at a. So this delta function, it is not a function, because here on one side we have that the integral of this function is 1, so could be like the unit step function, and here we have infinity times 0, so this cannot be. But if we take it as a operator that allows to do that the integral from a to a plus e of a function times the delta function of Dirac is that same function evaluated at the time t equals a, then this is called the Dirac function. That is not a function, it's not a truly function because of this, but it is a operator that allows to do this. And just in other video we will see that the integral of the Dirac's function is the unit step function, or other way is the derivative of the unit step function is the impulse function, that is the delta function of Dirac.